Okay, everyone, this is a video for Lab 2, and Lab 2 is about nonlinear function models. Nonlinear functions. So in particular, two models are important. One is the exponential model. So this containing exponential growth and exponential decay. And the other one is the quadratic model. Okay. And let's have a look at the first question. So the first question is about exponential models. So it says in the early stage of the AIDS epidemic during 1980s, so the number was first increased, the number of cases was increased by about 50% every 6 months. And the starting data is this 1600s. And so the first question is to get the model. So it says find a function that predicts the number of people infected by years. But here in the question it gives like 6 months, so it's half a year. So 50% for half a year, 50% increase is the total amount is 1.5. So for a whole year should be 1.5 square, right? So 1.5 square is 2.25. So that's like the number we need, and the function is 1600 times 2.5 to the power t. Okay, that's the first question. And the second question is use this model to estimate the number of people infected by October the 1st in 1986. So from the start of 1983 to October the 1986, how many years have passed? Like to the beginning of 1986, 3 years have passed. And from January the 1st to October the 1st, it's 9 months, right? 9 months is 9 over 12 is 0.75. So it's 0.35 year, and plus the 3 years, right? So in total we get 3.75. So that's the time t, and you just plug this t to this expression. So the number of people infected would be this, right? And you need to calculate this number out. And that's the first question about exponential model. And then next question is about like quadratic model. And okay, so a group of friends set up a repair stand to perform bicycle tune-ups during the summer, and so they try different prices each month to maximize their profit. And the table is a relation between the profit and the bags, the demand of the bags each month. And their relation is satisfies a quadratic model. And the first question is to get a precise quadratic model. Okay? And the quadratic function is in general form is this, like px equals ax squared plus bx plus c. And you just plug in these three pairs of data into this model, and you get three equations, right? Like 10 bags per month, and 30 bags per month, and 50 bags per month. And you get these three equations for three unknown variables, and you solve this system of equation, you get a is approximately negative 0.5, and b is approximately 37.84, and c is this number. Okay. And then you get this function, and rewrite it like complete the square, you get px equals this. And as you can see that this function maximizes when this negative term becomes 0. And it becomes 0 when x equals 37.84, right? And when x equals this number, and right, we can draw this graph here, like these three data here. And this function maximize at somewhere here, right? This number is this. So that's the graph. And then the last question says the corresponding price related to x is 80 minus 2p. So x equals 80 minus 2p, and you solve for this price. Okay? This is the second question. Okay, and third question again is about exponential functions. And the beginning data is this. And from November the 1st to November the 30th, we get the cases increased to this number. So assume our exponential model IT is the initial data times e to the RT. And this information says from November the 1st to November the 30th, we 29 days, right? 29 days have passed. So I at 29 equals this. And you plug in 29 for t. And using this relation, you solve for the number r. Solve for r. After you solve for r, you get this function. Every number you know, all the numbers you know, and the next question is like predict the number of infections after 100 days. So you just plug in t equals 100 to the whole expression to get this number, okay? This is a question. Okay, the fourth question is again exponential model, but here is exponential decay, right? Instead of exponential growth. But the idea is exactly the same, right? So the half-life is this. Is 5.27. That means e to the k times 5.27 equals 1/2. And by this relation, you can solve for k. After you know k, and you set at equals 1, and you solve for t, right? That's the time that the sample decay to 1 gram. Okay, that's question 4. And question 5 is a quadratic model. And so in which year was the oil production the greatest, right? The question is to find the maximum point, right? You just need to similarly need to complete the square of this quadratic function. After complete the square, you get this. And as you can see, at x equals 100, you get the maximum amount, which is 12.9, right? This is the max amount. Right? And you can sketch the graph like similarly, right? X equals 100, you get the maximum amount, right? Something. I should use t here, not instead of x. T here. Yes. So here is t, here is p, and when t equals 0, you get 2.9. Yeah. So the graph is kind of like this. Okay. Yeah, that's all.